what's a car company doing here?
Great question.
Great to have you.
Great to be here.
I'll do a little setup maybe, and then we can go from there.
Sure.
We all saw cars get computers. Even before now, I think the commonality on understanding this is there are more computers in a car than in a home. And all of us have probably been involved somehow in watching that happen or making it happen. It's in a pretty constrained environment generally for driver attention reasons. In that story, we saw OnStar long ago. We saw Ford come in with Sync, with Microsoft. And for those here who haven't been tracking, Paul Mascarenas is a longtime Ford guy and a serious engineer. So he has his chops in the engineering world.
If there is such a thing as a serious engineer.
Well, I think there is. And so prior to becoming kind of the visionary guy, the strategic guy, you had to do this day-to-day what works thing. And during that process, there was a decision point where it was kind of like go more toward the OnStar-like world or go more toward the Apple-like world. And you guys made the box choice. You decided to go toward where these guys all live. And I think there was some cost in making that decision and reversing course and going that new way, which to me was a stroke of genius. But that is a part of automotive history, I think, which not only put Ford into the lead, but which will give you years probably of advance versus your competitors. And the only other thing I think it's worth mentioning here is that we were at CES and saw Alan Smith and who led us to you. And one of the things we were looking for was this question of, is there really a second revolution afoot in car computing? And the reason for looking was that because of the stereo, because of the Apple, because of that little plug there that allows any Apple iPhone to plug into your sound system, and because smartphones use the same plug, and because there are 40,000 micro apps and growing on the smartphone, it seemed as though despite all of the regulatory attempts to shut down and constrain what's allowed in the cockpit, the opposite was going to happen. And a whole new zoo of animals was going to show up, and there would be a revolution in car computing. And when we saw what you guys were working on with your various new, it seemed to us like, well, these guys get it. So welcome to FiRe.
Thanks.
Very happy to have you with us. And I hope in our brief time you can help teach our friends here a little bit about how Ford thinks about car computing revolution number 2.
Great introduction, Mark. Thanks.
Yeah, right.
I mean, first of all, as you mentioned, this is my first time personally at FiRe, so thanks for the invitation.
Great to have you.
I think it's the first time that Ford has actually been represented at the conference as well. For us, it's really a great opportunity to be a part of the conversation, and we're very pleased to be a part of that conversation. I think to address your kind of opening, it's probably worth me just backing up a little bit and giving you some insights into the thinking that we've had over the past 3, 4, 5 years at Ford, and really how we've started to redefine our brand. And it really, if you just back up, maybe 5 years ago we were managing multiple brands. We had our premium brands, we had our Jag, Land Rover, Volvo, Mazda, even Aston Martin at the very top end. Through a process of divestitures, we're now focusing on the Ford brand as our global brand and Lincoln as our premium brand. So very much able to focus on those two brands.
And you've gone through bringing Alan Mullally on board during this same period of time, which is a really interesting move.
Yeah, and Alan joined us back in 2006, and consistent with the One Ford plan to focus on the Ford brand globally. He also laid out for us a very simple but powerful plan and strategy to restructure the company in terms of our manufacturing capacity, leveraging our global assets in terms of our product capability, our manufacturing capability. Clearly, as you all know, financing the plan.
So I'll just say, you took the money when you didn't need it, and then when the crash came, you were the only guys who didn't have to get bailed out.
We had the liquidity, the foresight to provide the liquidity to see us through the crash. and now we're in a position of being able to repay that debt, which is a good place to be. But consistent with One Ford, we defined a brand strategy for our products. Again, a very simple brand strategy. That was to deliver very high quality products that were safe, green and smart. And in the context of the discussion this morning, smart is where technology comes in. And as we apply technology in the vehicles, we're really doing that for three things. Firstly, for the customer, to provide a very high quality, very superior experience for the customer in a way that is relevant and in a way that is affordable. And I'll come back to that in just a moment. We're using it clearly to differentiate our vehicles from others. And we're using that to define our image and reputation as a company.
So your brands need to go through a transformation. It's going through already. You've cut them down, but you're also, it may be those foci you just mentioned, but you're also really changing the brand. You're not just redefining it in terms of segments. You're really changing the brand.
We're changing both the image of the brand and also our image as a company. Really defining ourselves as a technology company as well as a leading automotive company, which is a great space for us to be in. It's a great opportunity for us. Now, if we think about technology, and specifically coming back to your question now of, and the subject of our discussion this morning, in-car computing, we really think about that in three ways. One is technology that is built into the vehicle. So it's part of the hardware, it's part of the software that comes with the vehicle, obvious things being the audio system, for example, navigation system and the like. We then think about technology that's brought into the vehicle, and that comes back to the sync model, primarily mobile devices, and being able to provide through connectivity to the vehicle HMI really a superior experience for our customers, but to do that in a way that is seamless and to do that through an open architecture that really allows the customer to bring just about any device into the vehicle and connect through Bluetooth, USB and so on. The third area of technology is what we call beamed in. And this is really now getting into the area of connectivity outside of
telematics,
the car to infrastructure, car to cloud, and all of the benefits that we can. For example, maybe monitoring blood sugar levels, maybe monitoring heart rate or some other medical conditions, and then so a huge possibility. Really allow the customer to bring their own devices into the vehicle, to be able to use those devices. The point I made at the beginning is really to make sure this technology not only offers value, but it is affordable. And at Ford we use the term the democratization of technology. And what we mean by that is really making these technical solutions available to very high numbers of customers, millions of customers around the world very quickly.
Well, you guys
and
picked...
Sync is a perfect example of what...
Right. So you guys picked... I have two thoughts that come out of this. One is, one of the clues we had that this second revolution was coming, and the first clue, I think, was hearing that people were buying Fords preferentially over other brands because of Sync. And I thought, whoa, that's interesting. It's no longer just a bolt-on. It's no longer just one more feature. People are actually seeing the technology side of this story and making a buying decision based on that. And then the second part, well, go ahead.
Well, I was just going to comment. Actually, with respect to Sync, we launched that, I think it was 4 years ago now, in partnership with Microsoft. Actually, the Nuance colleagues as well from a voice.
We're all on the road here.
Engine, so we're doing good here. But we made a very conscious decision with the launch of Sync, and the conscious decision was to launch it in Focus. Ford Focus is our compact
Instead of going to the
small
highest
vehicle. It's a very affordable vehicle. It's around $16,000, $17,000. And the reason that we did that was for two reasons. One is obviously affordability. And we wanted to show that this wasn't a premium technology. This wasn't something that we were only going to offer in our high-end Lincoln vehicles.
Which had been the history of some of this stuff before.
Exactly. We're going to ground it. The second was the demographics. And if you think of the demographics of our customers that buy the Ford Focus, they're a younger, more techno-savvy type of customer. So the early adopters were there. From there, we've very quickly migrated across all of our vehicles. And
before you go on, I think there's also an international benefit. Because when you're facing low-cost vehicles from other worlds, right, whether you're facing them on the streets of New York or facing them somewhere else, by adding this magic to it, you add something which is truly proprietary and truly distinguishing between a Focus and some other car.
Yeah, and that comes back to kind of second reason that we use technology in the vehicles. The first is for the customer, relevance, value, superior operating experience. But the second is to differentiate our products. And clearly, for us, Sync has been a huge image builder in terms of the reputation of the Ford and Lincoln brands, and continues to be one of the core technologies that, and just for the audience, I think most people know we've now taken to the next level with what we call Sync 2 or My Ford Touch, which really now integrates a much superior HMI in terms of using a touch screen in the center stack area of the vehicle, integrating with the steering wheel and cluster controls. But most importantly, and coming back to Paul Ritchie's discussion earlier, in terms of the voice engine, it goes from a rules-based, command-based structure to what we call flat grammar or natural conversation. More than 10,000 commands can now be recognized. So whether you're using the audio, the navigation, some of the services, climate control in the vehicle, it's a much more natural conversation. Still, a lot of room for improvement, a lot of development ahead of us, but going from Gen 1 to Gen 2 is just a massive difference in terms of your ability to naturally interact with the system.
Right. This is My Ford Touch and My Lincoln Touch, too?
And My Lincoln Touch.
Yeah. Are they different?
No, they're different in terms of the way the screen graphics are presented, but the engine behind it is the same engine.
Okay.
And that, again, is part of the strategy of leveraging these technical building blocks, the pieces that the customer doesn't see across all of our vehicles, but then presenting them in a different way, depending on the brand or the segment that we're in.
Right. So now I want to pretend that a car doesn't have wheels. All right? If you like sound, we people who like music have long known that probably the best sound experience in your daily life is when you get into the car, if you make the investment in good sound systems. Extend that to computing, communications, other tasks, nav things, information about the world around you. Many of us have created kind of a cockpit where we work, but it makes sense to me, both because of the physicality of the car, like you talking about medical measurements, and because of the amount of time we spend in cars, that wheels or not, it becomes a complete multi-sense, multi-HMI, multi-interactive platform for the driver and or for the passengers, regardless of the wheels. Is fair enough?
Well, as a car guy, it's hard to pretend that cars don't have wheels, but let's try.
We can add the wheels back in a minute.
Let's try to imagine it.
But you know what I'm saying?
I do know exactly. And
you're designing a perfect cockpit for those things.
Yeah, and let me just. I've got to talk like a car guy, but we've got 4 key elements to our product strategy, not the brand. The brand is defined in the way that I described, but as we develop our vehicles, we think about the design. They've got to be great to look at. We think about the driving experience. They've got to be great to drive. The third thing, though, that we say is they have to be great to sit in. And I think in terms of great to sit in, you can imagine there's no wheels. And then the fourth is fuel economy, class-leading fuel economy. Come back to great to sit in. The analogy that we use there is really creating this environment that we could describe as being a second home on wheels, second office on wheels. It's really an extension of your everyday life into the vehicle. And that gets to, obviously, comfort, quality of materials, the technologies that we put into the vehicles, audio systems, co-branding with partners like Sony, THX for our Lincoln vehicles, co-branding with Microsoft for Sync, and really creating this very familiar environment. It's a comfortable environment if you're driving the vehicle, but at the same time it's got this familiarity and offers the ability to extend your life into the vehicle for productivity reasons and basically to enhance the operating experience with the vehicle.
Right. So in terms of the let's say a single driver, we've seen some work in various brands where the car knows you for whatever reason. And how deep do you feel like you guys are going to go with customization or personalization of the technology around the driver?
Also a great question, and I think the answer is the possibilities are almost endless.
Right.
Clearly we started, the industry started with very simple memory features in terms of seat settings, mirror settings, steering column settings. We've now got memory features on climate control, so you can set your preferred temperature in the vehicle and so on. They were really in the context of, as I was describing earlier, built into the vehicle. If you now think about what you can bring into the vehicle, you can personalize that experience further by using, for example, a key fob or even using your mobile device. And there's a lot of examples of using it as a key, using it to personalize your settings and so on. However, that's all still a relationship between the car and the device. Where you naturally go is using things like biometrics, so maybe fingerprint recognition or iris recognition, where the relationship then is very much with a person. It's between a vehicle and a person, not between a vehicle and a device. And what that gives the possibility, and I think we're still a little ways out in terms of robustness and reliability of the technology. What that means, though, Mark, is you could rent a car here in California, you could fly across with me to Detroit, you could pick up a car at the airport in Detroit, and through biometrics, that car would know that it's you,
right,
and it would customize to your settings, as opposed to the last user or what has ever been pre-programmed.
And whatever is out in the cloud.
Yep.
And so
and
you have three layers of storage here that are.
Yeah, it's this car to device, car to infrastructure, car to cloud, and that kind of hierarchy. And the possibilities, and I kind of said at the beginning, it's almost endless in terms of what we can do here.
And we haven't mentioned car to car yet. I think that's possible.
Yep.
And there's a lot of talk about collision avoidance and that kind of thing. Are there other levels of communication between vehicles that are useful?
No, we talk about V2X, and that's vehicle to vehicle, or it's vehicle to infrastructure, car to car. Big picture vision is cars that don't crash.
Yeah.
33,000 fatalities a year, that is way too many. We think we can apply technology in a way that significantly reduces that number. And we can do it in two ways. One, we can have cars that communicate with other cars.
Right.
And we can use DSRC to really help us with that, dedicated short-range communication
I hate to throw this in at this particular moment, but it's so relevant.
Okay.
There was a paper published this week on ants. I don't know if you saw it.
No, I didn't.
And the amazing thing was, so ants lay a trail. A lot of people have studied where the trails are laid and all that science. But this is the first study on how ants travel down the trail. And it turns out that their speed is constant. They never have a traffic jam. And so then the study was, why don't ants have traffic jams? And there were a number of answers to that. But I thought, I'm going to be talking to a car guy here, on collision avoidance. And if you add more ants, still no traffic jam. And they maintain the same what's called flux, regardless of what the density of the cars is and how many cars you put in. Whereas normal human drivers, if you increase the density, traffic jam, you get bunching. So I'll send you a copy of the paper if you
Yeah,
want.
good. I was going to say it's because ants don't drive, but
They don't drive. But if a car-to-car system could behave like ants, you might be able to maintain
well,
high
actually,
speeds.
it actually can, because there are really two things that we're doing with car-to-car. One is safety, and obviously having cars communicate with each other and understand their proximity and communicate with smart intersections, for example, is really a great enabler to reduce the likelihood of an accident. Though in terms of traffic management, you can do exactly what you're describing. And in fact, the density of vehicles that we need equipped is not as high from a traffic management, traffic flow perspective as it is from a safety perspective.
Mm-hmm.
So we can manage speed, we can manage distance. I'm sure you've read about the work in the area of either semi or fully autonomous vehicles.
Yes.
You know, we can take a degree of control away from the driver in a freeway type situation, give control back at any point in time, but really manage traffic.
So do you actually see that, it's kind of a dream, do you actually see that happening where you pile into the car, you turn it on, say go to grandma's house and the office, and then I read a book while I'm...
I really do. You know, in my role, I sort of think about the technologies over a different time frames, sort of 0 to 3 years, we're loaded, we're in a production program, we are going to launch. 3 to 5, we're in advanced. 5 plus, we're into kind of research and some fundamental work. I think we're still in the 5-year plus from a semi-fully autonomous perspective, but it's very real. The technology is very capable. There are certainly some issues around liability. Just like in the aircraft industry,
well, I was thinking, it's just like collision avoidance or
driver in
or
command. So, you know, the discussion around the vehicle is fully autonomous. You can sleep, you can read. You know, it's a little bit way out. It's technically possible, but I think we're always going to put driver in control.
Right.
So we'll always be able to hand back, or we'll always be able to take over.
It's an autopilot that comes off or goes on and has...
But, you know, we for example, and we're talking technology here, we've already launched in our Ford and Lincoln vehicles and some of our competitors too, park assist devices. So, for example, the vehicle will park itself. You know, that's an example of autonomous operation. It's low speed, it's a confined area.
It works better than human beings, actually.
It works. It statistically does work better. You might find one driver that can beat the system, but statistically, on average, you're better off using the system. So, you know, we can do it, and we've demonstrated capability. We have adaptive cruise control today that manages speed and distance.
I mean, as we talk, I'm just kind of evolving a new understanding of this whole thing. And the word autopilot was what stuck to my roof of my mouth. So, wouldn't it be natural? Why don't we have cruise control? But the obvious thing would be autopilot. And at some point, 5 years from now, you could say, okay, you know, the normal thing would be the autopilot's on. And any tricky stuff coming in, going out, or whatever, you handle that. But basically, just like a jet pilot today, that's a complicated cockpit. Autopilot on, right? 10,000 miles later, autopilot off. And it's not that they read well, they do go to sleep sometimes, it turns out, but
and do other
at least
things.
you can do something else. So there might be a higher level of interaction with the world that you're doing while you're awake, and the system is taking care of the nav stuff and all of the machine stuff and all of, and you're there kind of inquiring about things on the ground. Maybe you want to make a reservation in a restaurant.
I think the only difference, Mark, is a great analogy. The only difference for us is the environment that we're operating in, and there are way more noise factors when you're in a road situation. A lot more things that can happen. It's a much less controlled environment. You haven't got air traffic control, monitoring, so on. That's not to say, though, that the technology capability is not there. And not to talk in detail, but you've seen the Google work that they've been doing on autonomous vehicles, which is just fantastic.
140,000 miles.
It's just fantastic, and capability is absolutely there. And actually, even earlier this week, on Monday, I was at a meeting in Washington with a group of folks, and we were talking about wireless communication, exactly where we're talking now, car-to-car, car-to-infrastructure. And
so I'm going to just throw out this idea of, I don't like there are a lot of things I don't buy, like the magnetic stuff in the road and where that talks to the car. But I certainly buy collision avoidance and distance detection And I also, but the American, I suppose it's around the world, but some people will not accept. They'll just want to go in the fast lane in the Autobahn, and that's out. But you can imagine lanes in a highway where the 4 lanes, these 2 lanes are reserved for those people on autopilot. And they may go faster and not have a traffic jam because guess what? They're like ants. They're not like the other guys. And you have to have the sticker and the RFID and the identification, and you're in, and that's all certified and checked off, and off you go. And you're not going to be like doing this stuff all the time, which creates a lot of problems. And some of the noise you're talking about is gone. So if you're on I-5...
And I think that's the way it will be done. There'll be dedicated lanes for autonomous vehicles. There'll be entry and exit conditions.
Yeah. Perfect.
But when you're in the lane, the vehicle is doing the driving for you.
And that's fully doable.
Yeah, it is.
I mean, all you need is a lane. You don't need anything else.
And we have the dedicated lanes for commuters today, and so on the HOV lanes. So,
we're 9/10 the way there.
We are. So
it's very cool.
It's a lot of fun, isn't it?
Yeah, it's excellent. Well, it's great to have you guys pushing so hard and being leaders, seemingly careful but unafraid. I mean, you're ready to go forward. And that's not only a blessing for the American car business, but it's just great in general, worldwide. I think that platform is now going to be exciting again for folks. We have about 4 minutes, so I think if there are people here who would like to ask questions, please do. There's Steve.
Sort of a simple question, which is not in the short term, but in the 5-year plus term. How much do you think about the infrastructure assurance in things like smart intersections, et cetera? In the same context today that we have national infrastructure security issues, if all of a sudden I automate, therefore centralize all the controls on all the highways, if I can alter those systems, I can really make a mess. And so the concept of integrating today, in the most early stages of the architectural design, the tools that we forgot at the water plants, the utility plants, the nuclear plants, et cetera, so that we have really integrated cybersecurity in all of that infrastructure right from the get-go. Can you make any comment on that?
Yeah, it's a really great question, and I think in the time we probably can't discuss it in detail. Maybe we can hook up later. But in the meeting that I mentioned earlier in the week, we really talked about 3 things. We talked about policy issues around security, around privacy, around liability. We talked about the technology itself, and then we talked about the application of the technology. Clearly, all of this needs to be done in the context of an appropriate policy that governs what we're doing. We even talked, I think, last evening about some of the technology that's available, some of the solutions that are available to us. It's really how we deploy those within a controlled framework. And it's absolutely a top of the agenda issue. Thanks for the question.
I'd like to add one thing, Steve, which is ants are decentralized. They are. And one of the most amazing thing about hives and ants is how they do these amazing social things with a bottoms-up design. And I would guess that that might be one consideration for car companies, that instead of having an uber centralized control, you build a bottoms-up system which works together.
Exactly. And we also, Steve, we talked about possibilities with electric vehicles and working with the utility companies and the charging and so on. That's another area that we haven't discussed today. But again, the possibilities are just tremendous.
Yes. So we have another. There we are.
Christine Thompson, Informing Arts. My question has to do really with some of the social implications, and probably most of us in the room have had the experience of having to talk to parents who are seniors about removing, basically pulling the keys away because it's no longer safe for them to be on the road, and all of us will face that possibly as seniors ourselves. So the question I have for you are, what are the social and infrastructure and political obstacles to realizing your vision so that when we become seniors, we're not going to have to lose our keys?
Well, the idea is that you don't lose the key. We launched a technology called MyKey, which was basically aimed at teen drivers. And it allows the parents, in this case, to set maximum speeds, audio maximum volume for the radio, to control whether you can drive with your seatbelt on. We thought we were going to get some pushback from the teen drivers, but what we've actually found is it's a really popular feature because it means they're actually getting more access to the vehicle. Parents feel more comfortable giving their young drivers, and I've got my own teen driver, the car in a more controlled environment. So again, we can use technology to overcome potentially some of these social concerns. There is still the issue that we alluded to earlier of privacy. And clearly we don't want to get into a kind of a big brother's watching everything that you do in your car type of situation. But certainly in terms of being able to use the technology to make vehicles more accessible to more drivers in more conditions is certainly a huge possibility for us, and one where we're really using technology to be a part of a solution in a bigger societal context.
And maybe to phrase my question differently, clearly one of the issues seniors have is vision impairment and things of that sort. I can easily imagine how highway situations we can provide more guardrails, if you will, to sort of keep them safe. The question is in more rural areas or aging towns where the infrastructure, the roadways, et cetera, are not as amenable to change, what can the car companies do to make vision impaired people safe on the roads point to point?
Well, my personal view is we're still, many, many years away from the vehicle really being in control, in the sense of not having a capable driver that can actually, assume command, assume control as a condition allows it. But in the way that we were talking about earlier, we can absolutely use car-to-car communication. We can use car-to-infrastructure. We can use car-to-cloud to significantly reduce the number of risk factors, particularly in rural areas where you've got unmarked intersections, you've got unmarked railroad crossings, you've got all kinds of things going on. You haven't got the benefit of good street lighting, for example. We can use technology to help in those conditions, but I still believe there's going to be for example, you're talking about vision impairment. There's going to be a minimum vision standard that is going to be required for anybody to hold a driving license, and that will be continuing for years and years. But we can absolutely use the technologies to help us and make the world a safer place, make the world a better place in terms of traffic management and environmental impact.
And with that, we have exhausted our time. Thank you very much.
Thanks for letting us be a part of the conversation.
Absolutely.
It's been great.
Yeah, you bet.
Thanks.